This is a follow-up question on the previous one from Johnston textbook, Mechanics of Materials. And then this one, we need to determine the factor of safety for the cable anchor in problem 1.49. You guys make sure to check that one out before we go to this video, because a lot of information about the areas and the values that we have for ultimate stress are covered in the previous video. So make sure to check that one out before moving on to this one. It should be showing up at the end of this video. The video is gonna pop up, so you can watch it there. And we know the force P in this one is 2.5 kips, and we know the two dimensions that we have for A in the figure. We know that one's 2 inches and B is 6 inches. And based on that, we need to find the factor of safety in this system. So we are dealing with two different things in here. If you look at the free body diagram that I drew in the previous question, so we have the load P that is going to exert a tension force to the plate that we have. So because it's in tension, the area that is tolerating this the stress would be where we have the hole located, or this area in here. Obviously this is a 3D question, and the area that we have would be the area that I'm shading in this rectangle. So in the previous question, we have the ultimate strength for plate, which is 36 KSI, and we also have the ultimate shear, or the bonding stress between the plate and concrete, which is dealing with these areas. So we have one rectangle on top, one at the bottom, and also have these two rectangles on this side. And we have this 1.3 KSI. So these are the givens in the question. And based on each of these, we can find one factor of safety. And at the end, we have to pick one of those factor of safeties, and I'm going to explain which one. So let's start with the tension that we have in the plate. So we're going to find the factor of safety based on the tension in plate. So we have the ultimate strength. We're going to find the ultimate force in here, and the area that we have, as I said, is the area of this shaded area, which would be A minus D times the thickness. And what we're going to do in here is that we can find the ultimate force. We know that this will be equal to multiplying these two, 36 times. We have A in the question. A is 2 inches minus D is the diameter of the hole in the plate, which we know is 3/4 or 0.75 inch. So 2 minus 0.75 times the thickness, which is what we have in here. So our T is 1/4 inch, or the thickness, times 0.25, and we can find our ultimate force in here, 36 times. So 36 times 1.25 times 0.25, or 11.25. Now that we have the ultimate force, we have factor of safety is equal to the ultimate force over P. P is a given in this question, and we know it's 2.5 kips. So this is going to give us kips 11.25 over 2.5, and this is going to give us one factor of safety. So 11.25 divided by 2.5, and that's going to be 4.5. So that's the factor of safety that we get based on the tension in the plate. Now we're going to move on to the factor of safety based on the shear stress on plate, or the bonding stress that we have based on the bonding stress that we have between the plate and concrete. And there is a note in the previous question at the end that we're going to neglect the normal force on this part of the plate that is in concrete. So that's why our bonding stress is referring to the shearing stress. So this time we have ultimate shear, which would be ultimate force over the area. We showed the area with A prime in that question, and basically is what we explained in here. So it's the area of these two surfaces. We have 2AB. So one of these rectangles, the area would be A times B. And since we have one on top, one at the bottom, so 2AB. And for the red part, we have, again, one at the front, one in the back. So 2B, and the thickness in here would be what we have as T. So 2BT, and here we can just factor 2B will be A plus T. So I'm just going to put that in here. Our PU would be the shear stress, the ultimate shear stress times the area, which was 2AB plus 2BT, or we can just factor 2B in here. So 2B times A plus T. So the ultimate shear stress, again, we don't have it in this question, but if you just go to the previous question, that's a given, which we know is 0.3 KSI. And in the previous question, we actually have this value based on PSI is 300 PSI, which would be pound per inch squared. And if you want to have it based on kips per inch squared, we're just going to divide it by 1,000 in order to get it in KSI. So 0.3 times B, our B is 6, and our A is 2. So 6 times 2 times 6 times A was 2 plus T is 0.25. And let's calculate our P. So 0.3 times 12 times 2.25. It's going to give us 8.1. So the factor of safety is 8.1, or the ultimate P over what we had for P 2.5. Let's divide that by 2.5. And that's going to give us 3.24 for the factor of safety. Now the question is, so from the tension in the plate, we got 4.5, and based on the shear stress on the plate, we got 3.25, and we're gonna pick the one that is the smallest because that's basically our weakest component in here, because the component with the lowest factor of safety is the most vulnerable to failure. So if that part fails, it can compromise the entire system. And that's why we're gonna pick the one that is smaller. And basically the other thing is, if we go with the higher one, 4.5, we have the same force, 2.5, and if we multiply 4.5 by 2.5, we're gonna get something more than 8.1. So it's gonna exceed that ultimate strength that the system can tolerate, and it will compromise the entire system. So that's why we're gonna pick the 3.24 is the factor of safety for this question, because the lowest factor of safety is the most vulnerable to failure. So yeah, that's going to be our final answer for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.